Hey y'all, how you doing? Miss Lee here. So today I'm going to talk to you guys about cross reducing, also known as cross canceling. It just depends on the way your teacher says it. Not every teacher teaches this. Sometimes I do, just depends on where we're at most of the time. Near like the end of the year, I'll talk to you guys about it. But here we are. So why would this be helpful for you? Why is this considered a math hack? It just really makes fractions so much more easier to deal with. If you don't like reducing, if you struggle with reducing big numbers, this will be for you. So what I would do is, in the case I just multiplied across with this fraction, I would end up getting 198 over 396. Now, my question to you is this something you want to deal with? Because you're going to have to reduce this. This cannot be a final answer. This is an even number, and that's an even number. And if you're like me, I'm not about it. So, yeah, absolutely not. So it's called cross reducing. Cross. So when you guys see a sign at a railroad, it says railroad crossing, and it's an X. So you're gonna really just look diagonal, like crossways, not across, crossways. So what I'm gonna do is I'm just gonna use my favorite thing, a T-chart. So here we go. I'm going to use the numbers crossed from each other, diagonal from. So I have 9 and 36. And I'm pretty much just going to break this down until I cannot break it down anymore. So I can take out a 3. And 3 times what is 9? 3. And 3 times what is 36? 12. And then 3 and 12, 3 can equal both of them. Now, if you remember my divisibility rule video, which you probably don't, but I do have one. So if you look at this, you're like, they're not going to be divisible by each other because they're not both even. But if you add 1 plus 2, it equals 3. And 3 equals 3. Therefore, 3 can equal 12. That is the 3 divisibility rule. If you add up the numbers and 3 can equal them, then 3 can equal that number, period. So here we go. I'm going to take out a number 3, and I'm left with 3 times 1 and 3 times 4. These are your new numbers. So what you're going to do is you're going to cross this off, and in place of the 9, I'm going to put a 1. And in place of the 36, I'm going to put a 4. Okay? So you could rock with this, but also look at these numbers across from each other. 11 and 22. Well, look, they're double. So that means, look, 11 and 22. This is 1 and 1. This is 2 and 2. So 11 can equal it. So I'm going to take out 11. Think about it. 11 can equal 22, 33, 44, 55, 66, 77, 88, 99. And then it goes on to multiple digits. But here we go. 11 times 1 and 11 times 2. So up here, instead of 11, I'm going to replace it with 1. And instead of 22, I'm going to replace it with 2. Now, this looks ugly, right? It's not cute. All you got to do is rewrite it. So I got 1 and 1 times 2 and 4. Come on. Come on. 2 and 4, that is a half. Period. That's cross canceling, cross reducing. We'll do another one. We'll do 2 more actually. All right, here we go. So I'm going to review multiplying mixed numbers. I love a good review in a review. So here we go. In order to do this, my bottoms stay the same, and the academic vocabulary word for bottom number in a fraction is a denominator. So those stay the same. And remember that. The denominators stay the same. So here we go. Nobody likes, this is what I always do. Nobody likes being at the bottom of a pay scale. No, thank you. Less money. I'm not about it. Everybody loves being at the top of a pay scale. More money. That's how I remember where to put my X and my plus. So my X, my multiplication and my plus. So here we go. 5 times 2 is 10 plus 2 is 12. And then I have 3 times 2 plus 1 is 7. All right. And then look, 5 and 7. Now, cross reducing. Oh, I forgot such an important detail, by the way. You can't cross reduce until you have a multiplication sign. You can't cross reduce until you have that railroad crossing sign. I should have said that in the beginning. It's too late. We're already almost done. So here we go. 5 and 7, they don't reduce. So these are going to stay. I'm not worried about them. But 3 and 12, well, we just did that, didn't we? I can take out a 3 because 1 plus 2 is 3. And 3 equals 3. Therefore, 3 can equal 12. All right, so 3 times 1 is 3, and 3 times 4 is 1. So I'm going to replace these. That's my workout for the day. I'm totally kidding. I'm going to replace the 3 with a 1 and the 12 with a 4. Now, if you want to rewrite this with the other numbers, feel free. I'm all about it. It doesn't look that bad to me, so I'm just going to go ahead and multiply across because I'm cool with it. Like, it's fine. 4 times 7 is 28, and 5 times 1 is 5. Now, you cannot leave this answer like this. You cannot leave this answer like this. So we have to turn this into a mixed number, and I did a video on this. So here we go. I got to divide, and my denominator, well, I do 50, first in, top in. In this case, I have a top and a bottom number, so my top number goes in. My denominator stays the same, so I'm just going to set my fraction up. My denominator stays the same. It's going to be 5. All right? So by the time I'm done this and I have my remainder, there's only one place to put it. So here we go. 5 fits into 2. Not at all. 5 fits into 28 5 times. 5 times 5 is 25. When you subtract that, you're left with 3. Well, the only place you could put it is here. Now look, I don't have to reduce. I'm already done. Last problem. Come on, you know I had to hit you with a division problem. So here we go. In order to do this division, well, I guess you can't really see those dots, right? In order to do this, we cannot just divide across. It does not work like that in fractions. We keep, change, flip. So I'm going to keep 4 over 7. I'm going to change that sign. And because I changed the sign, you can't just change a math problem like nothing. It doesn't work like that. We wish it did. Math will be easier. Okay, because I changed that sign, I have to change this. And the only way I can do that is to flip it. So here we go. 4 and 1, it doesn't reduce. But let me take out 7 and 14. What can I take out of 7 and 14? A 7. I know some of y'all thought too. It's okay. I do that too. 7 times 1 is 7. And 7 times 2, that's where you got the 2 from, is 14. When you see 7 and 14, you just always think 2. Same with 2 and 10. You'd be like 5. And you'd be like, wait, but that's not what I asked. So here we go. Instead of 7, I have a 1. And instead of 14, I have a 2. Now, I use the same color marker on that, so I'm just going to change it because that blended in. All right. And then 4 times 2 is 8. And 1 times 1 is 1. And any number over 1 is itself. I hope this is helpful for you. Bye.